We're going to identify the hydrogen ion donors. Those are known as Bronsted-Lowry acids. And hydrogen ion acceptors. They're known as Bronsted-Lowry bases. We're also going to do problem 57 because it refers to the same set of equations. And that wants us to label the conjugate acid-base pairs, which are acid-base pairs that only differ by a proton. So you should write that down in your notes if you don't have that already. I'm sure you do. You might recognize already nitric acid is one of our strong acids, but even if you didn't, NO3, look at the nitrate. It has a proton before the arrow, and afterwards it's lost it. So, right, what donates the protons is the acid. So that's going to be your acid, and this is going to be its conjugate base. Remember, acids, base, conjugate acid-base pairs differ by the proton. It has the proton before, lost it afterwards. There's your pair. Now, where did that proton go? Well, it's only one other thing is there, water on the reactant side. So water picked it up. So water gained that proton. Water is the base because it accepted that proton. Afterwards, it became the hydronium ion. So if you go, that's going to be the conjugate acid. So if you go right to left, hydronium is the acid and water is its conjugate base. B. Remember COOH? Recognize that. That's your carboxyl group. That's your organic acid. That H is going to be lost. All right, so this is going to be our acid because acids lose protons, and water again is going to act as the base because it gains protons that was lost by the acid. The conjugate acid for water is going to be the hydronium ion, okay, and the conjugate base for the acetic acid is going to be the acetate anion. So this is going to be your conjugate base. All right, again, notice they only differ by a proton, these pairs. All right, let's go on to C. All right, this is ammonia. We already know that's a base. You notice the N, the nitrogen, has 3 hydrogens before, and afterwards it has 4. Did it lose an H or gain an H? Well, you go from 3 to 4 by gaining something. So you gain an H here, and that would make it a base. Bronsted-Lowry bases gain protons. Therefore, this is the conjugate acid of that base. Conjugate pairs are differed by 1 proton. Where did that H come from? That extra H, it must came from the water. So water acts as the acid in this case. And by losing one of these H's, what does it turn into? It turns into an OH. Doesn't lose an H, it loses a proton. So it turns into the hydroxide anion. So that's your conjugate base. All right, so there's your pairs, and there's your pairs. All right, and over to the last one. This is just the opposite of B. Put it right next to it. It's just the flipped version of B. The acetate anion over here is going to gain that proton. All right, so gaining protons. What is that? Bases do that. Where did it get it from? Got it from water. Water, in other words, donated a proton. What do we call those? Acids. All right, this is your conjugate base. This is your conjugate acid.